Hello everyone, welcome back to another video covering OCR Further Maths. Today we are doing another past paper question from the 2019 Pure Core 2 paper. As you can see, this is a question on Maclaurin series, and the first part of it is a pretty standard question, part A, and then part B is just applying what we've done in part A to a specific situation, and it can be a bit tricky, but as you can see, it's a show that question. Usually there's a very simple technique to kind of getting all the marks to show that questions, even if you don't get the first part. So we'll first start with part A. And as you can see at the top here, I have put the formula that you were given in the formula booklet for the Maclaurin series. So that's really important that you're able to use the formulae in the formula book to help you during these questions. So part A, use differentiation to find the first two non-zero terms of the Maclaurin expansion of ln half plus cos x. So straight away it says non-zero terms, so you know that maybe f of 0 might be a value of 0, and f dash of 0 might have actual value, so you might need to do more than just the first two terms, is what I'm trying to explain here. So the way we do Maclaurin series, we have f of x equals f of 0 plus f dash of 0x plus f double dash 0 x squared all over 2 factorial and so on and so forth. So the first thing we need to do is just write that f of x is equal to ln half plus cos x. Then what we do is we find f of 0, because that's the first term here that we're trying to find out, and all it is ln half plus cos of 0, and cos of 0 is 1, so we know that this value is ln 3 over 2. So that's the first term done. Then we have to find f dash of 0, and the way we have to find that out is first we have to differentiate f of x, and then we can plug in 0 after. So first let's find f dash of x, which is, so here we have ln of another function, so we have a compound function, so we know we have to use chain rule. So the first thing we're going to do is we're just going to differentiate ln of x, and that would be 1 over x. So if we just differentiate this, then we get 1 over half plus cos x, but then because of chain rule we have to multiply by the derivative of the inner function, so that would be times by half differentiates to 0, and cos x differentiates to minus sine x, so minus sine x. So then if we then try to find f dash of 0, that would be equal to minus sine of 0 all over half plus cos of 0. Now sine of 0 is just 0, so this whole thing is equal to 0. This is a 0 term, and we need non-zero terms, so we need to then go again and double differentiate, because we need two non-zero terms. So if we now double differentiate, the way I would do this is probably quotient rule, because we have a fraction here. So f dash of x is a fraction, minus sine x over half plus cos x, so we're going to use quotient rule. Now if we put this term as u and this term as v, we know that using quotient rule, this is just a thing we do normally in A-level maths. It's v u dash minus u v dash all over v squared. So on the side I'm going to write u equals minus sine x, u dash equals minus cos x, v equals half plus cos x, so v dash equals, these v's and u's look very similar, but try to make them more clear when you're writing it. So v dash is equal to minus sine x, and then all we have to do is just plug these values into the formula. So half plus cos x times by minus cos x minus sine x times by minus sine x again, all over half plus cos x squared. Then the next thing to do is to plug in 0 into this. It's not cleaned up, but because we're not trying to find a solution, we're just trying to find f double dash of 0. We can just plug it in directly. So f double dash of 0, half plus cos of 0, as we found out before, is 3 over 2. This should be in brackets here. That would be times by minus 1. Then we have minus sine of 0 and sine of 0 both 0, so this is just minus 0, all over 3 over 2 squared, and this gives you minus 3 over 2 all over 3 over 2 squared. Now, these 3 over 2's cancel out, so what you get is you get negative 2 over 3. Now, we have the value of f double dash of 0 and f of 0, so we have two non-zero terms, and all we have to do is just plug this into the formula. So what we get is f of x equals f of 0, which we found out was ln 3 over 2, and then the next term is f dash of 0x, but obviously we know f dash of 0 is 0, so then we go to the next term, and it's f double dash 0 over 2 factorial x squared, so that would be plus negative 2 over 3 x squared all over 2 factorial, and we know that 2 factorial is just 2, so that this will cancel out with this, and our final answer is ln 3 over 2 minus x squared over 3. Now, we'll move on to part B. So, as you can see at the top, I've written down the solution to the previous part, part A, and so now we're going to move on to part B. So it says, by considering the root of the equation ln half plus cos x equals 0, deduce that pi is approximately 3 times by the square root of 3 ln 3 over 2. So, the first thing that we should notice is that they have made ln half plus cos x equal to 0, and we know that f of x equals ln half plus cos x because that's what we did in the previous part, where we tried to write the Maclaurin expansion of that function. So what we're going to do is this f of x that we found in the previous part, we're simply going to make it equal to 0, and we have to try to deduce that pi is approximately this value here. So to be able to do this, we're going to have to find a solution of x in this specific case. So what we're going to do is we're going to write ln half plus cos x equals 0, and it says to consider the root of the function first, so that really does, it's kind of common sense really, that you'd have to be able to solve this equation, find the value of x, and then plug it into our expansion that we found in the previous part. So first we have to get rid of this ln, so we raise both sides to the power of e, and this gives us half plus cos x equals 1, e to the power of 0, anything to the power of 0 is 1, so that gives cos x is equal to a half, and that would give x is equal to pi over 3. You could use a calculator, but this is a common value, so I'm just going to delete all of this, and we can use the fact that we know, obviously you should never cross out your workings in the real thing, but just for space reasons, I'm going to write at the top that x equals pi over 3. Now, we plug f of pi over 3 here, and you get that ln 3 over 2 minus pi over 3 all squared all over 3 is equal to 0. So now we just have to manipulate the algebra a bit. Obviously, actually, this should be approximately, because a Maclaurin expansion is an approximation, especially when we've only done it to 2 terms. But for now, I'll just stick with the equals. And what we have to do is just rearrange this so that we get pi as a subject on one side. So this is pretty easy stuff. We take this term over to the other side, so we get pi over 3 all squared over 3 is approximately, I'm going to start using approximately now, is approximately equal to ln 3 over 2. Times both sides by 3, we get that pi over 3 squared is approximately 3 ln 3 over 2. Square root both sides, pi over 3 is approximately the square root of 3 ln 3 over 2. And then finally, we just get pi is approximately 3 times by the square root of 3 ln 3 over 2. And that's our final answer right there. So you see, this part is fairly easy. If you just split it into, and kind of listen to the question where it says, consider the root. So you first solve to find the root, the value of x, where this function equals 0. And then just manipulate the algebra and use what we've learned from the previous part to solve the question. So thank you guys for listening, and I'll see you in the next video.